So in this video, I'll be introducing the concepts associated with one-dimensional kinematics. So one-dimensional kinematics, this is chapter 2 in the Walker textbook. So one-dimensional, I think you know what that means. One dimension means we live in a three-dimensional world, but we're only going to think about things happening in one direction. So if we're doing a horizontal problem, we only care about this direction. I don't care what's happening up and down or any other direction. If I'm doing a vertical question, I only care about what's happening vertically. So that would be like the drop tower. So the drop tower, people go up and come back down, right? There's no motion this way. At least if all goes well, there's no motion this way. So we're not going to worry about what happens this direction, but only vertically in this problem. So all of our mathematical models here will be related only to one-dimensional motion. So one-dimensional, we understand that. Kinematics is a big fancy word. It means motion. Okay? So one-dimensional kinematics, that's about motion in one dimension. So concepts to worry about. Distance and displacement. A distance is a path length. I drive 15 miles to get from my home to school. So my path might look like this. The total length of the path, 15 miles. Not SI units, I know. I'm sorry, I'm American, I still sometimes think in the wrong units. Displacement is a change in location. So if it's 15 miles this way, actually the distance from my house to my work is only 10 miles. So a displacement is from start position to end position, how far did you go? Distance is if I count every step along the way. All right, so distance is a path length, displacement is just your change, initial location and final location. Speed and velocity. Speed, you probably know what that is. Speed is a distance per time, miles per hour, meters per second. Velocity is displacement per time. Okay, so distance is related to the path length. So my speed is related to which way I'm taking to get there. Okay, it's the total distance per time. Velocity is a displacement per time. So actually, if I start here and I go over here and then I turn around and come back, I had some sort of average speed over that whole time, stayed kind of the same. My total velocity, my displacement, if I compare my starting point to my ending point, I didn't go anywhere. My displacement's 0. So my average velocity is actually 0 in that case, because it's my displacement per time, start position compared to end position. So speed is concerned with only about how fast you're moving. Velocity is concerned with how fast you're moving and in what direction. Both of those things factor in. So velocity includes direction. All right. So speed and velocity, this is sort of a change in position over time. Acceleration is your change in velocity over time. You think of acceleration as in your car, you put the pedal down and you go from 0 to 60 in 7 seconds. So what you're talking about is going from 0 miles per hour to 60 miles per hour. That's a change in speed in 7 seconds. So change in speed over a time. Change in velocity per time is acceleration. So that's how those are related. Okay, so that's speed and velocity. These are change in distance and displacement over time. Acceleration, change in velocity over time. Free fall. So when an object is in free fall, that means the only thing affecting it is gravity. So this stapler is not in free fall. When I let go, it is. So while it's in the air and the only thing affecting it is gravity, then that's called free fall. We'll also look at motion maps. Motion maps are sort of like stop motion photography. If you took a video and then looked where is something at every frame, that would be a motion map. We'll also look at graphs of position, velocity, acceleration, and see how those graphs relate to each other.